Tangents and normals, of course, are important lines as well. We're going to look at it in two different ways, one using the parametric coordinates and one using the Cartesian coordinates. First of all, let's look at it using parametric. So, the tangent, there's our basic parabola, x squared equals 4ay. Parametric coordinates, of course, 2ap, ap squared for the point P. There's my tangent. So, to find the equation of a tangent, we need two things. We need a point, we need a slope. This is where calculus came in handy. So, all right, y equals x squared on 4a. The derivative is x on 2a. That, of course, is the formula that allows us to find the slope. Of course, I didn't have to rearrange it. We could have used implicit differentiation if I wanted to. And I could have said, well, differentiate x squared, I get 2x. Differentiate 4ay, I get 4a times dy dx. And again, I get x on 2a. So either way, we get x on 2a. We want to know at the point 2ap, and we get a very interesting result. It just turns out to be the parameter. So the slope of a tangent at any point is always just the parameter. So P for my one here. Now, I could have done it yet another way. If I'd done it via the parametric coordinates themselves and said x was equals to 2at, so dx to t, 2a. Y is equal to at squared, so dy to t is 2at. Dy dx then would be dy to t times dt dx. And we simply get t, the parameter. Well, we're at the point where the parameter is p, so when t equals p, the slope's p. So yet a third way of finding that information. Let's put it into our point slope formula. Y minus ap squared, px minus 2ap, and I'll make it y equals, there we go. Y equals px minus ap squared, the general form of a tangent. Tangents from an external point. So here's a parabola. You'll notice this time I've just made the focal length equal to 1, probably just so I don't have to write a down all the time. Doesn't really matter. So the actual external point, so it's not on the parabola. So it has coordinates 3, 2, this particular point. Now from any external point, it's possible to draw two tangents in. There's one of them. The other one, of course, would go up the other way. It would hit the parabola at a particular point. So 2ap, ap squared, but in this case a is equal to 1, so the point would be 2p, p squared. There's the other one, which would hit at, say, q. Let's give it parameter q, so 2q, q squared. So y equals x squared on 4. So once again, differentiate it. We know the slope of the tangent would be x on 2. So at the point P, we get dy dx as P. Again, basically just finding the equation of the tangent again. So there we go. Same answer I got before, obviously, except this time I don't have a's in there. There's the equation of the tangent, px minus p squared. Now, once you do this once, you don't do it again and again and again. If that's the equation of the tangent at P, guess what the equation of the tangent at Q will be? Exactly. We just replace the parameter. So the equation of the tangent of P, px minus p squared. But we know it goes through the point 3, 2. So I could sub that in, and I can find the actual parameter. One parameter will be P, one parameter will end up being the Q one. So there's our quadratic, which has those two solutions of, in this case, 2 and 1. And so therefore, I now know the equation of the tangents. Well, if the two parameters are 1 and 2, I'll just go back and substitute into our general form that we found, and we get those two tangents, so y equals x minus 1 and 2x minus 4. So that basically is a way of finding the equation of a tangent when we don't actually know a point on the parabola itself, but we still know a point that it goes through. In this case, it was the point 3, 2. Another important thing we do with these is finding the point of intersection of two tangents. So again, here's our parabola, 2ap, ap squared. So again, I'm not going to do it for a third time. We go and find the equation of the tangent, y equals px minus ap squared. And there's the one going through Q, which we can assume is QX minus AQ squared. We want to find that point of intersection, solve them simultaneously. So let's solve them simultaneously. I think it would be smart to eliminate the y, seeing the coefficients the same already. P minus QX is AP squared minus Q squared, but of course P squared minus Q squared, difference of two squares. So the P minus Q will cancel. By the way, why can I cancel the P minus Q? Yeah, because P and Q are different points, so there's no way those parameters are the same, so P minus Q won't equal 0. So it is okay to cancel the P minus Q there. So X is equal to A, P plus Q, there's the X value, sub back in, and there's the Y value, APQ. So there's our coordinates for the point of intersection. A, P plus Q, so the sum of the parameters, A, PQ, the product of the parameters. All right, let's have a look at normals, yet another line we're interested in these things. So there's random points. The normal, of course, is perpendicular to the tangent. So, okay, we go and find the slope. We know it's going to turn out to be the parameter. So the slope we want, the one for the normal, will be minus 1 on P. Point slope formula, it's, there we go. Don't know why we don't write that in general form, but sometimes you see it in general form. But I've written it in X plus PY is AP cubed plus 2AP. And of course, sometimes we like to find the intersection of those as well. So let's do that one. 2AP AP squared. Of course, the one at Q then, don't derive it again, it's going to be X plus QY is AQ cubed minus 2AQ. Let's find those simultaneously. This time the X's are going to cancel nicely. All right, right-hand side, difference of two cubes, that'll factorise. And now again, I can eliminate the P minus Q from both sides. And we end up with P squared plus PQ plus Q squared plus 2. So let's sub in now to find the X value. And, oh, of course, there we go, minus APQ P plus Q. So quite an interesting point of intersection there. The X value is minus A, the product of the parameters times the sum of the parameters. And the Y value is just a mixture of the parameters. There's no neat little way of saying that, I suppose. P squared plus PQ plus Q squared plus 2. All right, 9F. Oh,